Okay, here we go. I haven't actually looked to see, quiet. I haven't looked to see how many of you maybe practice the factoring. Um, well, all sorts of things are happening up here. Anyway, um, if you feel like you're struggling with factoring, that's just going to be on your own time. Meet with me, or if I'm starting to factor stuff up here, and you don't quite get it, we can sit down together. I don't remember how long I left the Delta Math open, that I opened up over the Thanksgiving holidays, but I can open it some more. There's always an honors pre-cal and calculus, and really those two places. What shows up sometimes is just gaps in your learning that are sometimes not even your fault. Maybe you weren't taught that in middle school and all of a sudden you're expected to know it in high school. I'm just saying that happened to me a few times, of just like weird little things that I just wasn't good at, that I needed extra practice on, and I was like, something's wrong with me, like, why do I not know this? But you can make up that lost ground if you feel like that you need to, especially quickly now with your maturity in mathematics. What we're going to do is we're going to be solving trig equations. What you want to do is actually actively look at the directions when you encounter a problem. And now I have to find my worksheet. That's pretty hysterical that I just lost mine. Okay. You'll see why I have you where you recognize common things. Like if you run into something, you go sine of x is 1/2. You'll realize why we're doing these memo quiz things, because last year I told you for the first time in a long, long time I didn't give memo quizzes until I got to this section. I'm like, oh my gosh, you didn't know your stuff. Like I would go sine of theta is 1/2, and people had just been skating along, studying for tests and other type of quizzes, and I realized they weren't really good at it. And so we started the memo quizzes last year, and so I'll always have them again, because your minds are already all thinking 30 degrees because of what we've gone through. That's just a start, isn't it? That doesn't mean those are only angles that I want. I want you, this would have helped me greatly had I thought of this myself. I'll constantly be throwing pictures at you so that you see the picture of a sine graph. It all depends on what the original question is. If I say arc sine of 1/2, the only answer is 30 degrees. Just like square root of 16, the only answer is 4, okay? But if I say sine of theta is 1/2, then I'm on that long trig function that's not 1-to-1. That means you've just got to tell me every answer that you can find, which we started on a little bit last class before Thanksgiving. We probably weren't paying attention and all ready to go somewhere. But I'm sure you caught it a little bit, and you'll catch it. We talked about it in the term of birthdays and leap year and all sorts of things. Something else I was going to say before we start. Oh, I had to also really, really, really drive home that difficult concept of an inverse trig function, what was happening with it. Because there is going to come a time that we're solving, and it happens all over the world to engineers, probably going to happen today, where you're really needed an angle. And a lot of common angles happen in like construction and architecture. But if you're actually wanting to point a satellite somewhere to receive a signal or something like that, a lot of times it's not going to land at something that you know. It might be 53.7 degrees. Do y'all see what I mean? But if I need to know the sine of theta equals 0.785, I'm going to have to use my calculator for that, right? On my calculator, all I've got is to push inverse sine. So do y'all see I've got to take that with a grain of salt. I don't even know what that means. But I've got to say thank you for the help. Now I've got to finish the rest of it myself. So do y'all see what's going to happen when you go to push that arc sine button? When you push that second key to go to inverses, you should always... You're like a queen. You should always be wary. It's like danger, danger, you better be smarter than your calculator right now, okay? Because it's only going to go tick, tick, tick and give you the first answer it runs into, positive or negative. Or if it's arc cosine, it goes all the way around. So know that, okay? All right, so I am on this page that says solving linear trig equations. Do y'all find this page? Sorry, I'll try to make sure we're all on the same page. It says solving linear trig equations. Has anybody found it? I think Grace has hers. Solving linear, there you go. All right. I think I maybe even did one or two off of this page. By the way, hopefully during class today, I'll ask for volunteers to come up here and actually work some problems and see. You can come up here with a friend and y'all can talk about it together. I know Mr. Hill's class quite often gets on the whiteboard, but ours is so big, I think I would lose the impact of what I'm trying to teach if we go up to the whiteboards. But I do want you actually working up here some, so we'll see. I'm at the second part that says solve from 0 to 360. All right, notice that this is in degrees, so your brain or your calculator needs to be in degrees, whatever it is that you're using, okay? So if I have 4 cosine x plus 1 equals 3, I don't yank out the calculator and start just typing into it because it can be so time consuming to solve these on the calculator. In fact, I want you to hear this. It won't mean anything to you a whole lot, but as you go through honors pre-cal and calculus, I hardly ever push those inverse trig function buttons, actually, to tell you the honest truth. I hardly ever do it. I'd much rather see a picture of everything that's happening, and I'll show you what I mean by that in a little while, okay? Let me go as long as I've addressed it. Suppose I want to know the sine of an angle that equals 0.785. I'm probably not going to push inverse sine because it's only going to give me one answer, whereas I might be looking for a different answer depending on what it is I'm doing, okay? Where is sine positive? In the first and second quadrants. Arc sine's only going to give you the first quadrant. But if you're actually turning a satellite dish, you might want to turn it more than 90 degrees. Do y'all see what I mean? Okay? So what I'll teach you to do, and this is just a heads up, and then we'll abandon this in just a minute. Into my calculator, I'll actually put the sine wave. I'll put sine x. And then into y2, I'll put 0.785. And you'll actually see every time it hits. And then you can pick and choose with something calc intersect that most of you may have done. You can actually just move down and find the ones that you need. That way you're seeing everything. You're not depending on this very limited inverse sine function. So to be quite honest with you, I'm the type that hardly ever pushes inverse sine. I want you to know what happens when you do. You're only going to get a limited answer. All right. Interestingly enough, the picture helps you see something like this. Why, that would be nonsense, right? When is that ever going to equal 3? It never will. Not with an amplitude of 1, right? Do y'all see what I mean? Okay. All right, now, having said all of that, it takes a while to grab your calculator, check your mode, type something into Y1, type something into Y2, let it graph, and once we go over it together, then move around and do calc intersect. That takes a while. And if it can be done by hand quickly with algebra, people can be sitting there looking at you like, why are you doing all of that? So you're starting to learn in pre-cal the importance of algebra is if we can do it quickly with algebra, we will. If we can't do it with algebra quickly, we'll grab our calculator and find the answers, but don't we still need to understand the pre-cal to even make any sense of what we're doing with our calculator? Okay? In fact, to me, I've probably said this to you before, not just to me, it actually makes you have to know your pre-calculus better if you're going to pick up your calculator and use it. You have to know what you're doing, okay? So having said all that, let's work this problem. I would subtract 1 and divide by 4, and I would be glad I didn't type this in my calculator because I can move forward. I'm told in this problem that whoever's looking for this is looking from 0 to 360. Actually, the first thing that comes to my mind is the first thing that will come to my calculator's mind, which is 60 degrees, okay? And if I pushed inverse cosine, that's what it would give me. But girls, that isn't the question, is it? It's cosine. It's this picture, cosine x, from 0 to 360, and it equals 1/2 twice. Do y'all see that? Okay, I think you know the other time's 300 because of all students take calculus. All right. Now let's pause and say if I wanted to find all real solutions, which before the last class probably seemed somewhat impossible, okay? I've got to find all of the times it equals 1/2. Doesn't it happen an infinite number of times? Okay? I don't think any of us are going to live to infinity here on this earth. So when I ask people like when their birthday is, they'll have a lot of them, but we don't know how many you're going to have, right? But these graphs go on and on forever. And so, you know, when I go, Brianna, what's your birthday? Blah, 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 blah. You know, she'd have to give me 16 years so far, I think. 17, 16 years so far, okay? And then we'd keep on going into the future until she's 185. We would keep having birthdays, okay? However, all she's got to say, and I can't believe I don't know what her birthday is after all this.
August 16th.
16th, okay. Every calendar year is going to be August 16th, okay? You know, if there's 3 siblings in your family we talked about, then those 3 will happen every calendar year. Unless you're born on February 29th, then it happens every 4 years. You get your interim grades twice a year. You get your final grades twice a year. Blah, you know, all that kind of stuff. The ACT's offered on set dates in September, June, and whatever. The dates are almost always the same per calendar year. I know when it's going to be offered. I just have to check the dates. Do y'all see what I mean? Okay. So there is a way to tell. If I'm tutoring somebody for the ACT, I'll say, you know, I like for people that I'm tutoring to always take it in June. A lot of times the June one might be a little easier. You're through with your math, you know, that kind of stuff. So I know that it's going to happen in June. Okay? So if I say all real solutions, let's get a couple. Let's go through one cycle of cosine and name a couple of them. Sorry. Go through one cycle of cosine and name a couple of times that it equals 1/2. Pick up every one that you can per cycle. It's like all the people in your family's birthdays, and then you're going to turn the calendar and write them down for next year and next year and next year. And I guess you could turn back the calendar and write them the years before, right? How often are these going to repeat themselves? What's the period of this graph? 2 pi over 1, but if I'm on degrees, what's the period of the graph? 360? Okay, so I'm going to say plus 360. That's not the answer, and we talked about this in the last class, but I know I need to talk about it a lot more. And that depends on if the question says find all real solutions. I would pick up a couple, like 60 and 300, pick every time it happens in one cycle, and then repeat the cycle. Now that actually, 60 and 300, doesn't even give me these two. Doesn't it give me these two? If I take 60 and 300 and add 360 to them, I'm not even talking about these two anymore. Do y'all see what I mean? Okay. So what I want to do is say 360k, or n, or whatever letter you want to use, where k is any integer. Now, why do you have to say that to me? In your homework, you don't have to write that down, unless you mean something other than that. There's times I want k to be every odd integer. I don't always want k to be every integer. But if you don't define what k is, somebody could say 360 times 2/3. Do y'all see you want them to go 360 times 1, 360 times 2, 360 times 0 gives me these two. 360 times negative 1 would move me back 360 degrees. Do y'all see if I define this as an integer? It will take me like this. Where it equals 1/2. I found these two, and then when I add 360, it lifts me over to these two. Do y'all see what I mean? Or if I subtract 360, if k is negative 1, it takes this one back here and this one over here. I'm sorry, that's really ugly, so I'm going to do it with my fingers. All right, so I have these two. If I add 360, it takes me to this calendar year. It takes me back here. It takes me back here. It just takes me wherever you want to go. In the last class I think I even did something ridiculous, like 360 times 50. Go out 50 years. If you go 60 or 300 plus 360, 50 cycles down the road, you're still going to land at the cosine that gives you 1/2. Do y'all believe that? You understand that? Okay, it's based on reference angle. Lindsay?
So I understand like how you write it out, but like the question you said, like if you wanted 50, would you do 300 plus 360 times 50 or
Mhm.
60?
Both of them. Either one.
Oh, you would, and then.
This is saying every angle that could possibly happen to you.
But then, yeah, so like in the 50th cycle, you would get, in each cycle you get 2 answers.
Yes.
So you'd have to do both.
Not necessarily. What's happening here is it depends on what you're doing. You got to tell somebody all the possible answers. They might be looking for a certain thing. So they might want to say 60 plus 360 times 50. We're just guaranteeing when they do that, they're going to land in an angle that answers this question. So this guarantees, I'm saying you could do it to either one and you will definitely land on an angle. By that statement, I've said every angle that could possibly work. It could happen at 60, it could happen at 300, and every period that you go back and forth, I've incorporated every single angle that you could possibly run into where cosine equals 1/2. Okay? So Lindsay, I wasn't looking for a specific angle. I was supposed to name every single angle where it could possibly happen. Okay? Big deal. Of course, I'm going to start with one that has a period of 2 pi or 360. But y'all see, it's important. If the graph shrinks, you better make sure you add the correct period to it as you go. With tan and cotan, I don't want to add 360. I'll jump over some stuff. I'll leave things out. How often do tan and cotangents repeat themselves? Every pi, or how many degrees? Every 180 degrees. So we'll have to watch the period as time goes by. But I've done an awful lot with one problem. So let's do the next problem without all of that, okay? So the next problem is, sorry, I had this ready for calculus. Let me get rid of that. Okay. Number 4 is 4 sine x minus 2 equals 0. Are y'all okay if I just jump straight to sine is 1/2? Okay? I don't want to push arc sine. I'm thinking to myself like of the sine wave that's going like this forever. That equals 1/2 over and over again. Okay? First thing I think of is 30. And all students take calculus. 150 is the first 2 times in the cycle. In the picture here, sine hits 1/2 right away here and here. Early on at 30 and later on at 150. And then want it happen every 360 degrees, but time out. I said I was not going to do more with this problem. This problem said name everything you can between 0 and 360. Is that every time it happens between 0 and 360? That's every time it happened between 0 and 360. Okay? All right, so watch the directions. All right, let's go to number 1, ironically, at the bottom of the page. Don't know why there's a number 1 at the bottom of the page, but it went 1, 2, 3, 4, 1, 1. So I'm at the second one at the bottom of the page. 8 sine x plus 4 root 2 equals 0. Any volunteers? We're doing this in what mode, by the way? Radians. Okay, anybody want to work it up here? Nicole's going to work it.
Sorry.
Okay. I like to see all this. You do. And where is it from?
0 to 2 pi, so 1 cycle.
Yeah. So now it would be at is that one right? Or?
It's a negative, so your reference angle's right.
Oh, never mind. I know what to do.
Okay.
Is that the eraser? So then it would be the one in the third quadrant, which is negative.
or 5 pi over 4, you don't need the negative.
Sorry.
Does that make sense, Nicole?
Yeah. I was just thinking
You were thinking
that
of
was negative.
negative.
Yeah. And then this one would be. No, is it 11?
Right before 2 pi, which is 8 pi over 4.
Wait, so it's 7.
7 pi over 4. Okay, great. All right, is everybody okay with what she did up there? Thanks.
Sorry.
So her job was to name everything that could happen from 0 to 2 pi. I want to keep throwing graphs in front of you. Actually, if I graph this, it's very interesting. Let's talk about our transformations for a minute. In fact, I wonder if I want to do this on Desmos. I'll just go in and turn on the calculator. And then we'll move to the next page. I've just hand selected problems, kind of like I did with identities. Calculator always takes a long time, so we'll go on and I'll come back to it. Okay. Again, the deal is with algebra is we want to be really good at it because we really can do it faster than we could do if somebody's going, well, I don't want to learn all that. I'm just going to do it on my calculator. They'll get really bogged down and go slower. So try it with algebra first. If you get something like sine of x equals 3/4, then you're going to have to use your calculator in some form or fashion that we'll talk about. Let me see if the calculator's up yet. Where'd it go? So slow. All right, while we're waiting on the calculator, turn to the page that says Practice Worksheet 1. Practice Worksheet 1. Still opening. All right. So we'll go to number 1. All right, number 1, we're solving this everything we can think of from 0 to 2 pi. I don't know if you noticed the one that Nicole did not have the 0 and the 2 pi included. Those are things we also expect you to watch for. Okay? Like now, if it happens to land on one of those, I can include the endpoints of the cycle.
Only including it for the 0.
Huh?
For this one, it's only like.
Oh, it only includes the 0. Thank you. Which makes perfect sense because isn't 2 pi actually starting the next cycle?
Yeah.
Okay. All right, so I have 4 cosine squared x minus 3 equals 0. I'm going to work this one since it's got a square in it. So I have cosine squared x equals 3/4. Everybody okay with that? All right, then I'm going to square root. And hopefully you've learned what this would look like. That would actually look like the absolute value of cosine, which would force you to have to say plus or minus. It's really happening on this side, but you've got to think about that. That's square root of 3 over 2. Is everybody okay now? Okay. All right, so I'm not even going to graph it right now. So what should pop in your mind is 30 degrees or pi over 6. And my answer is going to be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Why all 4 of them? As plus or minus. So I got to pick up every 30-degree reference angle. And I get to stop at 2 pi. Okay? How many times did I get it? 4 times, right? There'll be ways that we can do this if we were going to do all real solutions. If I said name all solutions, I could say all of these, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, plus 2 pi k, where k is any integer. You might know a quicker way, and I would take that. As we start to talk about better ways that you might look in the back of the book, and they might have their answer in a little bit shorter format than yours, can you think of something else I might do here? Is there a shorter way to list them?
Could you make it like a.
I'm listening.
Could you like, actually, could you do like pi over 6 plus the, oh, actually no.
What
I
about
was
that?
gonna say let me set like a domain grid. Like,
Oh, no, you don't have to like say it in a different way. I just meant like there's a shorter way to write this list.
I don't know.
Rebecca?
Uses to when you know when to make the square root of something positive or negative, or just positive.
When the problem's asking me this, It's not, if I've given you, like if I give you this, that's a bad example. If the square root is already on the problem, that means the person's already made the decision. Like this, 5 plus square root of 4, that's 7, okay? If the square root's already there. If you physically have to put it on there yourself, like this, all right, so Rebecca, look, at x squared equals 16, you're on the x squared function. Granted, you might have to square root to keep solving the problem, but it came to you as x squared, okay? And so that's when I would have to say plus or minus 4 when you put the square root on it yourself. If it comes with the square root, somebody's already decided on the domain. That help? So when you square root it, that's when you have to do it, because I didn't realize this until I was in pre-cal. Once we start doing algebra, we're actually changing the question. And so we've got to be aware that we are, okay? It's just like this. I don't have any idea what's happening out there. But anyway, it's just like this. It's a great question, Rebecca. If I've sine x equals 1/3, I'm on the big, huge sine wave. But I might have to push inverse sine to get me some help. But you've got to be aware of what the question was originally, okay? Any ideas before I tell you? I'll give you a hint. This is fine. I would accept this for 100% credit, okay? But you might flip to the back of the book and see this. Plus what? Oh, you're on the right track.
2 pi over 6.
Okay, let's pause for a minute. What's going to be the difference in this graph and that graph? Cosine x looks like this. What in the world would cosine squared look like?
It would look like that, but only above it.
It would look like this. If you square 1, you get 1. If you square 1/2, you get 1/4. So you still get some little fraction. These pieces won't look quite the same right here. Like these pieces will look a little bit different in here. But you're still squaring fractions to get fractions, and the highest thing you could do is square 1 to get 1. What's going to happen to this part right here? What's going to happen to that if you square it? It's going to pop up here and be just like that one. And so it actually shortens the period, doesn't it? Cosine squared, it equals numbers. Say this is 0 to 2 pi. Do you see how it happens more frequently? I don't think I actually labeled that right, though. Hang on. Oh, I didn't put my 2 pi in the right place. 2 pi would be right here. Okay, watch this. I'm going to hit the undo button. There's a cosine wave. Absolute value of cosine would literally just flip that little red part up top. That's all it would do, and leave the part on top alone. If you square it, the numbers are a tiny bit different. I'll show you what I mean. But let me undo that, okay? So now you could go out to 2 pi, but can y'all see that your cycle your repetition has been shortened when you square it? It's really not repeating every 2 pi, it's repeating every what? Pi. I could say plus pi k. Let's check. What's pi over 6 plus pi? What's pi over 6 plus pi? Elena, 7 pi over 6, isn't it? Let's look at our picture. Here's pi over 6, and here's 7 pi over 6. Aren't they 180 degrees apart? Okay. That is just what's the word I'm looking for? Just ignite a little bit of understanding of this in your mind. I'm going to keep throwing this at you until we're not at a point right now where I'm going to ask you to fully comprehend all of that. I'll just keep throwing these little things at you and you'll get it, okay? Hopefully my calculator's turned on by now. This is taking forever. Oh, good. All right, so let me show you what I'm talking about. Let's look at cosine x. Let's look at cosine squared x, which you actually have to type in like this. Now, this should not work, should it? that should not really give me cosine squared x. Right now it looks like I'm just squaring the x. So I usually like my students to type it in like this. Okay. However, these right now, after the first update of this calculator, probably 20 years ago, and the engineers at Texas Instruments made the decision that it's just faster. We need cosine squared and sine squared so often. I learned this from one of my students when I kept insisting that they put parentheses around the whole thing. They're like, I'm okay. I'm like, no, you have to. And they're like, please look at it. I'm like, okay. So anyway, what they did is by default, they made it a little easier to type in cosine squared. So if you want the cosine of x squared, you see you have to put the square down in there, which hardly ever happens. You usually don't want to square that angle anyway. You're just squaring the cosine of that angle. So we'll have 3 different colors going here. But first I'm going to go to, well, let me check my mode. Radians. All right, so as cosine's not turned on, but now let's look at the absolute value of cosine. Did y'all see what I did there? I might have to do of x, so I'm going to do that. All right. Can you see they're slightly different? If I zoomed in, you could certainly see they're slightly different. Absolute value of 1/2, the absolute value of -1/2 is just 1/2. The absolute value of positive 1/2 is just 1/2. But you see what happens if you square 1/2 or 3/4? You get another fraction, so it's slightly different. So cosine squared x and absolute value cosine x look a lot alike. They have the same period of pi. Okay? That was a lot in that problem. So let's move on. Okay, so, oh, I know I wanted to show you one more thing with the calculator, if I can find it again. All right, going back to the problem that we did a little while ago. Let me clear these out. I'm going back to the problem that said, if you think about your transformations on the last page, 8 sine x plus 4 root 2. And if you look, it says equals 0. So we're going to look at a picture of this and see when it equals 0. Do y'all see what I mean by transformations? The 8 gave it a really big vertical stretch, and the plus 4 root 2 moved it up. Do y'all remember that from algebra? It stretched it and it moved it up, but it definitely hit 0 a bunch. Do y'all all see what I mean? So I could go to second calc 5 or 2. Let's go to 2. Second calc 2. Did y'all see that would find me a 0? I'm going to go over here closer to it. And be to the left of it. Then I'm going to move to the right of it. And then I'm going to hit enter. And my first one is 3.926. Somebody get out a calculator and type in 5 pi over 6 for me. You might want to flip back to the page we were working on. 5 pi over 6. I'm sorry, 7 pi over 6. 7 pi over 6.
It's 3.66.
Oh, then I'm doing something wrong. Hang on. What were our answers on that? What did we get for number? Let me flip back. Something's happening. Hang on. Oh, here we are. Did we work that problem? Yes. I think that's the one Nicole worked. Okay, I'm sorry. Our answers were 5 pi over 4. So type in 5 pi over 4.
3.92699.
Did y'all see we got that answer? Okay. But you see why you want to know algebra? If I don't know algebra, I have to resort to this. I'm going to talk about this a little bit more. why I want you to see a picture of it is you can see that it happens like this. Okay, so I was actually literally want to see what makes it 0. Again, this is not something you have to be able to do right now. I'm just throwing lots of things, just hoping it sort of sticks to the wall, and we'll make it sink in later, okay? But do you see the first time was 5 pi over 4, and the second time in that cycle was 7 pi over 4. Do you see, for lack of a better word, these 2 birthdays right here? Don't they happen every cycle over and over again? So as long as you know the period of the graph, you can go forwards and backwards to where it all happens again. You just want to find every time it happens per cycle. Now going back to this problem to now try to make things sink in. Okay? You wouldn't have had really any way of knowing, other than if you were super intuitive about this, what was happening to that graph until your honors pre-cal teacher starts making you think about these things. Which you notice I didn't just tell you, we talked about it. I hope I made your brain start thinking what would happen. One of you said that it would be above the axis. I didn't tell you that, okay? So really think about these things. Which then, once you saw it, it shortens the period. So after this long discussion on this problem, I would accept this answer or this answer. They're both right. It's just that if you give all 4 of these, you're just kind of wasting your time. You could give me these 2 and land on the other 2 as you're going. Okay? We'll keep doing it. Let's stay on the page that we're on. So I'm on worksheet 1. All right. And I want to go to number 3. I don't think we're ready for number 2 yet. Number 3 is 3 cotangent squared x minus 1 equals 0. Any volunteers? Algebra work. Besides Nicole. Rebecca? Sorry, Nicole. You might want to work it and look up and see what she's getting, because you have a worksheet to work on.
This is
Number 3. Uh-huh. Okay, but you square rooted it yourself.
Oh, I know.
Okay, you're not finished. Okay. There you go.
Alright. And then,
Okay, girls, you're
tangent
supposed to be watching,
squared
listen.
Is this in radians? This is in radians. So that's over 6. So it's gonna be. Wait, nope.
Wait. You're flipping the wrong thing over.
I'm flipping the wrong thing over.
Let's
actually
change
flipping
it to
this over.
tangent. That might help you.
Over 3.
There you go.
Sorry.
Okay.
Okay. Comma. It's that one's there. That one is there.
Careful, you got to be in the 3rd quadrant
Oh, bottom.
because you do tangent.
Yeah, but isn't it plus or minus?
Keep going. You're right. Thank you.
I can just add.
Yeah.
mine. Okay, so if you have,
She's
sorry, there's a lot of squiggles everywhere, but
okay, listen. Shh.
So you solve for cotangent, and then you realize that cotangent is just like tangent. It's like 1 over tangent. So then we're just gonna flip everything over. So 1 over root 3 is gonna become root 3, and then 1 over tangent is gonna become tangent. And then after that, what you can do, because if you like go like this little thing. Is there any way I can like extend the page? I'm really messy. I'm sorry.
Yeah, you should be able to. There you go.
Okay. Because if you have like 1 over tangent, which is cotangent, and you have 1 over root 3, and you like do the cross multiplication thing, you get root 3 over times is equal to tangent.
Put
And
a theta or an A or something. That
Theta.
makes me feel better. Thank you.
Okay. And then since you got this, you know that theta is equal to pi over 3, because that's 60 degrees, which, because otherwise that would be root 3 over 3, because that's 30 degrees.
Oh, she was still working with cotangent. She, in her head, started working with tangent. So that's what she was just explaining to you. Brianna, if you look up, if we scroll up, her brain started thinking about like, oh, I've got cotangent, so I'm going to flip it over and do tangent.
I'm really trying to
If cotangent's 1 over root 3, what is tangent? Huh? It's just root 3. She just rationalized it before she thought about it. Okay? Do you see what? That's a great question.
So it is root 3.
It is
Yes.
root 3.
You don't need that. She doesn't really need that root 3 over 3. She was just going in algebra mode for a minute where she rationalized it before she realized she could just flip it over.
Okay. And then since this is giving me trouble. Okay. Well, since if it ever goes down, okay, I'll go over here. Okay. So since you have like tangent of, you know that theta is equal to root 3, like the reference angle, but it's positive or negative because you added your own square root thing. So that means it could be in all 4 quadrants, but that means also the period is pi. So you just do like, this is the first quadrant, this one would be the second quadrant, and then you just add pi. Because the other one would be like 4 pi over 3, which is really just pi over 3 plus 1. Plus pi. Okay.
Okay?
Sorry. This is a mess, but
No, that's great. Thank you. Okay, did y'all follow her work to this point right here? Did everybody follow her work? I mean, that's just algebra, okay? Then she square rooted. All right, hang on just a second. I mean, because this is how I would work it. I would work it just like she did. All right, girls, look. When I see cotangent, though, or secant or cosecant, I know at some point I'm going to switch over to the words I'm more familiar with. So once I get to this, where cotangent is plus or minus 1 over square root of 3, because she square rooted, she said plus or minus. At that point, I would switch over to tangent as plus or minus root 3 and then work it from there. Do y'all see what I mean? If I get cosecant of x is 2, I'm going to change that to sine of x is 1/2 and go on with my life, which is what she did in her head, all right? So she went from here to here. Root 3 called to her mind 60-degree angles, while some of y'all were still stuck on thinking it was a 30-degree angle, but you were looking at cotangent, not tangent, okay? So if tangent is square root of 3, we've got to pick up our 60-degree or pi over 3 reference angles. The instructions here said to give all the answers from 0 to 2 pi. Okay? And so actually I would list all 4 of them, because I would say pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3, because those are all the ones I'm going to run into by the time I get to 2 pi. Girls, listen. I would also take this, Rebecca, as long as you also, I guess I would have to ask you, do you mean it for this one and this one? I think that you maybe do by your comma, and by the way, I've been writing mine, okay? I would take that, so I'm going to discuss this. Rebecca means take these 2 and just, notice it doesn't say pi k. She didn't keep me going. Y'all see she found the first 2 she ran into and then said add pi because you're going to run into some more? And she just stopped, which gives me all 4. So there's different ways that I'm going to have to grade the test to see if what you wrote is true. She was probably thinking of the period of tangent is pi. Notice she didn't put a k there. There's no need for you to do that, but if you really are that perceptive and you do that, I'll grade what you write. okay? You don't want to do pi k though, which Rebecca didn't do, because then that would keep me going past 2 pi. She stopped
So
by adding.
the K is for all real solutions.
Yes.
Wait, how do you know when it's past?
It'll say find all real solutions.
Wait, so then what's the
If they don't give you a set domain, then you just have to find every number where they give it to you unless they say all real.
So then what's the difference between 0 is less than x and 0 is less than or equal to x? I mean,
Oh, if I ran into something like sine x equals 0,
yeah.
one of the times it equals 0 is at 0, so I have to look and see if it's included in the domain. It also happens again at 2 pi, and according to that domain, I wouldn't include it if they want the answer that way. Okay? Because if you're at 360 or 2 pi, you're technically starting the next cycle. It's really the beginning of the next one, not the end of the other one.
Yeah.
Okay? All right, so let me work one. Another one. Let's go to number 4. Number 4, I'm not going to call you up here to work it. I'm not going to ask for volunteers because I'm afraid that you would do something that would make me want to scream. And I'm being like, obviously, it would take a lot to make me scream. I can't remember if I've ever screamed at someone else. Probably my children. I do remember one time fussing at my older son, Nathan. I don't know what he had done because he hardly ever does anything wrong because he is so sweet. But he had done something, I don't know what. And I was, you know how your mom just gets like, doesn't take a breath. Did that ever happen to y'all? And like, how could you do that? What were you thinking? Blah, 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 blah. You know, I was just like, almost shaking my finger in his face. And he just looked up at me and goes, would you just spank me? Just to get it over with. Anyway, that may be the last time I screamed at someone. I just wanted to make a big point that if you do this, I might scream. Okay? Do not divide by cosine and start finding where cosine squared x equals 1. That will make me scream. If you think you're going to divide both by cosine, you've just opened the window on a cold winter day and thrown out a bunch of answers. Okay? If you could have divided by it, what could you do instead? I'll say it. And I want you to repeat this back to me every time I ask you. If it could have divided out, instead you could have factored it out and kept the answers that you need. So I'm going to factor this. Do y'all see that both sides have cosine in them? Okay? Set it equal to 0. Do not divide by a variable expression. Okay? Now I'm going to factor out a cosine. What's the first rule in factoring? Take out what's in common. Okay? That gives me cosine squared x minus 1 equals 0. I'm not really sure what you want to do with this part. I'm going to make this a difference of squares. Cosine x plus 1, cosine x minus 1. All right, so I'm not only looking at where cosine equals negative 1 and where cosine equals positive 1, what else am I also looking for where cosine equals what? Do y'all see that you would have thrown out a bunch of your answers if you had divided? Don't divide. Factor instead. Get it equal to 0 and factor. An alternative here in green, you could have set this factor equal to 0 and gotten cosine squared x equals 1. You put the square root on yourself, so this person would have said cosine equals plus or minus 1, which is what I have right here. So I'll just grade whichever way your brain went. Okay? All right, so cosine is 0 at pi over 2. And we're still going in this domain at pi over 2 and at 3 pi over 2. Cosine is negative 1 at pi, and cosine is positive 1 at 0. So Elena, to answer your question, cosine's 1 right here, and it happens again at 2 pi, but according to how this is worded, I only include the 0. Okay, so it happened here. Okay?
Oh, so it's like just restarting.
Yes,
Okay.
yeah. All right? I can't think of any other trickier way to say that. Now, if I graph this, cosine cubed x minus cosine x, let's see how many zeros we get. And no, you're not supposed to know what this looks like. cosine x, I'll do kind of the cheaty way and cube it like this. And then I'm going to go minus cosine x because I like to see where it equals 0. Let me pause for a minute as I start to give you some heads up on your calculator usage. Okay? And again, I think it would be a shame not to pull technology into this in the year 2019, almost 2020. Anyway, do y'all see if I didn't subtract cosine x and I'm only looking for where it's 0, which is beautiful? If I had cosine cubed, it's probably going to look pretty crazy. And cosine x, they're going to be swimming around on each other. I'm not going to be able to tell where they intersect. Does that make sense to you all? So I like to pull it over and make it one trig round. I don't know what I'm going to see here, but let's see. Let's make our window 0 to 2 pi. I'm going to back up a little bit because I know I have a little bit of something there. And let's go to 2 pi. All right, so now I'm going to make my window a little smaller because it really is hugging the axis how this looks. Let's go -2 to 2. All right, so between 0 and 2 pi, I see 1, 2, 3, 4 answers. Do y'all see them? And we got all 4 of those. Okay? All right, so let's do one more example and then we'll be finished right at 11:25. Let's look at number 6. On number 6, I have 2 sine squared x minus sine x minus 3 equals 0. This is why I said to practice your factoring. First rule of factoring, Katie would tell us, is take out what's in common. There's nothing in common, so I'll move forward. I'm going to factor the front, 2 sine x times sine x. I'm going to factor the back, 1 and 3. I'm going to have to put the 3 here and the 1 here because I thought it out. This one needs to be minus and this one needs to be plus. If I set this one equal to 0, I'll get sine x equals 3/2. And this one equal to 0, I'll get sine x equals -1. There's only one answer here. Sine is -1 at 3 pi over 2. Why am I ignoring this one? Sine x equals 1.5. Opposite of, right. I love the way you thought about the picture. Or if you think of opposite over hypotenuse, this can't happen, right? So I don't have to worry about that one. Okay? All right, so I had not posted homework yet, but you'll be working out of the book. But just another thing you want to do is keep bringing the packet to class. But your homework will be out of the book and our 8th memo quiz. Okay?
Thank you.